In this section, we're going to use first derivatives to be able to find out whether or not the function's increasing or decreasing. So the first thing I want to mention is that if f prime of x is greater than 0, meaning that f prime of x is positive, then f is increasing. If we see that f prime of x is negative or less than 0, then we know that the function is decreasing. We're going to use a first derivative test. Well, let me go back to this picture. I didn't really talk about, we can talk about the slopes of the tangent lines. You can see how they're positive, and you can see how the function's increasing. We have critical point right here, meaning the slope of the tangent line is 0. We have the slope of the tangent lines to the curve being negative. Notice how it's decreasing right through here. I also mentioned about critical points that they can be undefined at corners and cusps. The first derivative test is a test that we're going to use, and what we're going to do is we're going to first find the f prime of x. Once we find that derivative, we're going to test things from on the left of that value and on the right of that value to find out what's going on with the slope of the tangent lines. So notice on this picture, if the slope of the tangent lines are positive, then they change over to being negative. We know that we're going to have a max, and that's what the first derivative test allows me to do, is tell whether I have a relative max or a min. If f prime of x changes from negative to positive, we know that the graph is decreasing, then increasing, so therefore I have a minimum. So the first thing we're going to do is we're just going to look at this graph, and we're just going to write down the intervals of increasing and decreasing intervals. So if I look at this picture, I notice that my graph is increasing, 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 increasing until it hits 0 right here. So I'm going to go ahead and say that from negative infinity to 0, it's increasing. Then from 0 to 1, from 0 to 1, notice I'm using I'm using parentheses, meaning that those values are not included because the value at 0 has a slope of the tangent line of 0, and here at 1, the slope of the tangent line is 0 as well. So it's not positive or negative. So again, the slope of the tangent lines of the curves are positive here, so I know it's increasing. Then the slope of the tangent lines of the curves are negative, so I know that this part is decreasing. And then the last part from 1 to infinity, those slopes of the tangent lines are all increasing. So we are able to name the intervals of increase or decrease by looking at a graph or by looking at the derivative. The next problem we're going to look at is one where they don't give me a picture. Now, of course, I could use my graphing calculator to come up with a picture, but we're not going to do that. We're going to compute the first derivative, and we're going to test those values. So when I take the first derivative, actually, let's go ahead and rewrite this first. Let's say y equals x plus 4x to the negative 1. Now let's go ahead and take the derivative. I get 1 plus negative 4x to the negative second. It's imperative that I change it out of this form. So I'm going to say it's 1 plus, this would be negative 4 over x squared. It's going to be much easier to solve for my y prime. I want to know where those critical numbers are, so I'm going to set it equal to 0. And we're going to test those values. So I've got, when I move over my 4 over x squared to the other side, 4 over x squared equals 1. I'm going to come up here to finish this. I will go ahead and cross multiply. So when I cross multiply, I get 4 equals x squared, and then I'll square root both sides, which gives me plus or minus 2. Now, I'm going to also take note that not only do I have critical numbers at 2 and negative 2, I also have a critical number because at x equals 0, the y prime is undefined or does not exist. So I also need to include 0 as a value of testing whether it's positive or negative. Now, when I go to test the values, I'm going to test whether or not their slopes of the tangent lines of the curve are positive or negative. So I'm just going to pick a value between 0 and 1 first. I could start down here on the end, but I'm not going to. So between 0 and 1, what is the slope of the tangent line? I don't actually have to have the exact value. I will actually continue this on the next video. I'm getting ready to test the intervals, and so that's what I'm going to do right now. When I'm testing the intervals, I am going to just try numbers in between here, and I'm going to put them into the first derivative because I'm curious what's going on with the first derivative. Is it positive or negative? So I don't actually have to come up with the exact value. I just need to know if it's positive or negative. So if I test 3, that would be something greater than 2. So if I put 3 in here, I notice I get negative 4/9. So at 3, it would be 1 plus negative 4/9. That would be a positive value. So I'm going to put a plus sign above here, meaning the slopes of the tangent lines at the curve are all positive in this interval. If I try 1, put 1 in here, I get 1 plus negative 4 over 1. That would be a negative number. So the numbers between 0 and 2 are negative. All the slopes of the tangent lines are negative, meaning it would be decreasing. If I try negative 1, I have 1 plus negative 4 over negative 1 squared is 1. So I still have a negative value here. And then if I try negative 3, I have 1 plus 4 over negative 9, which would be another positive value. So that means the slope of the tangent lines are all increasing here. So what I'm able to do is identify those open intervals on which it's increasing. It's increasing from negative infinity to negative 2. Okay, because negative infinity is over here, up to negative 2. And it's also increasing from 2 to infinity. So those are my increasing intervals. It's decreasing from negative 2 to 0 and from 0 to 2. Let's try another one. On this one, I think it's much easier. We're going to find the critical numbers, and then we're going to find whether the function is increasing or decreasing. And we're on top of that, we're going to locate whether we have relative maxes or mins. What I was getting ready to say is I think it's easier on this one to actually not use product rule and actually just go ahead and multiply what is x plus 2 times x plus 2. Multiply this out. So I'm going to go ahead and do that. I get x squared plus 4x plus 4, and then I have x minus 1. When I multiply these together, I end up getting x cubed plus 3x squared minus 4. Now you may need to multiply those all out and to come up with this value, but to save a little time, I'm going to go ahead and just tell you what that equals. F prime of x then ends up being 3x squared plus 6x. Now we're looking for those critical numbers, so we're going to set this equal to 0. There are no values we need to test where the derivative does not exist because there's no fraction. We can factor out of 3x, and we're left with x plus 2. So that means there's two values I need to try right now, when x is 0 and when x is negative 2. So what I'm going to do is I'm going to create that number line that I did in the last problem. I'm going to label it this time f prime. I'm testing f prime. So I'm going to go back here and I'm going to circle that. I want to test the intervals. Here's 0, here's negative 2. We know that the slopes of the tangent lines are 0 at those. What's going on before it hits negative 2? Is it positive or is it negative? So if I try negative 3, and I put negative 3 in for there, I'll have 3 times negative 3 squared plus 6 times negative 3. Well, that is 27 plus negative 18. That's a positive value, so I know that all the slopes of the tangent line of the curve are positive here. Then if I try negative 1, I'd have 3 times negative 1 squared plus 6 times negative 1. Well, that would give me 3 plus negative 6. This is a negative value, so all the values are decreasing. All slopes of the tangent lines are negative. And then the last one, if I put 1 in there, I'm going to get positive, so I know it's increasing there. So I'll go ahead and first just write down that my intervals of increase are from negative infinity to negative 2 and from 0 to infinity, so those are increasing. And then my interval of decrease is negative 2 to 0. Now I'm also supposed to find those relative max or mins. What I like to do is I like to just go ahead and pretend that this is partially a function here, and I like to draw in, okay, well, it's increasing, then it's decreasing, then it's increasing. So I know here's max and here's a min. So I'll go ahead and write that in here, that negative 2 comma something is a max, and 0 comma something else is a minimum. We go back to find our y values from the original. This means y. I'll just go ahead and tell you what you get when you plug those in. You get 0 and you get negative 4. Okay, in this problem we're going to be doing the same things. I'm finding the critical numbers and finding the intervals of increase and decrease and the relative extrema. I'm going to go ahead and rewrite this first. I do not want to use quotient rule on a problem like this. It's much easier to take the derivative if we just go ahead and rewrite it. I will then reduce this to be 1 over x plus 3 over x squared. So then I can rewrite this as x to the negative first plus 3x to the negative second. Taking the derivative gives me negative x to the negative second plus negative 6x to the negative third. Now it's going to be hard to set that equal to 0 unless I go ahead and rewrite it. We have 6 over x cubed. Again, this is hard to set equal to 0 until I make a common denominator. So I'll start to do that, and my common denominator is going to be x cubed. So I'm going to leave this one alone, x cubed, and I'll have the 6 still on top. This one I need to multiply the top by x, so I have a negative x. I'll come up here to finish that. My first derivative ends up saying negative x minus 6 over x cubed. Now I'm finally ready to set this equal to 0. I'll take note that on the bottom, I need to test x equals 0 because it's going to be discontinuous. It's discontinuous on the function. And I also need to go ahead and figure out what the top gives me and where it's equal to 0. So if I do that, I get at negative 6, there is a critical point or critical number. We need to test those on an interval, so I'm going to put 0 and negative 6 on my interval, and I'm again going to be testing the first derivative. So when I go ahead and plug in my negative 7, because I'm going to test the negative 7 here, I will end up getting a negative value for my slope of the tangent line to the curve. When I try, maybe I'll try negative 1, I'd have a positive 1 minus 6, which is a negative 5, over a negative 1, so that ends up giving me a positive interval. And then the last one here, from 1, when I put 1 in there, I ended up with negative 7 over 1, which is a negative interval, meaning it's decreasing. So the intervals of decrease are from negative infinity to negative 6, and from 0 to infinity. So those are decreasing. And then our interval of increase is from negative 6 to 0. So this is where it's increasing. The last thing I'm going to do is mark my relative max or mins. So in this one I have decreasing, then increasing, then decreasing. So I have relative max at 0 and a relative min at negative 6. So I'll squeeze that in here. My max is at 0, comma, something, relative max. My relative min is at negative 6, comma, something. So where am I going to plug this in? We'll have to plug it back in for y value. So when I plug 0 up here, well, that's not going to be a max or a min because it doesn't exist. So there is no max. Remember, it was discontinuous there. So that's the reason why. Then I'll plug in negative 6. Negative 6 plus 3 is negative 3. Negative 6 squared is 36. That gives me a negative 1/12. So I'm going to really have a relative min on this problem. I'll go ahead and get started on this problem, and I'll have to finish it in the next video because it is a little bit longer. The first thing I want to notice is I want to take the derivative of this, and I need to rewrite this in order to take the derivative. So I've got sine x quantity squared, that's what that squared part means, plus sine x. When I take the derivative of this, I end up getting 2 sine x cosine x plus the derivative of sine x is cosine x. I can set this equal to 0, which will allow me to find my critical numbers. I can factor out a cosine x, and I'm left with 2 sine x plus 1. So when I solve for cosine of x, I want to know where the cosine of x equals 0, and where 2 sine x plus 1 equals 0, or truly, where the sine of x is equal to 1/2, or negative 1/2. From where I left off, I am going to figure out where this occurs. So the cosine of 0, if you think about your unit circle, the cosine of 0, the cosine of x is 0 at up here and down here. So that would be at pi over 2 when x is pi over 2 and when it's 3 pi over 2. So those would be two of our critical numbers. And then the sine of x is negative 1/2. Well, the sine of x is 1/2 at 30 degrees. So we're going to be talking about pi over 6. Well, it's not at pi over 6 though, because I'm looking for the negative portion. So if I use my saying all students take calculus, I know that it's in the third and fourth quadrant that the negative 1/2 occurs. So that would be at 7 pi over 6 and at 11 pi over 6, or 330 degrees and 210 degrees. So this is 210 degrees and this is 330 degrees. So these are my 4 intervals I have to test. So I'll make my number line and I'll place each one of them on there. So I've got 90 degrees, I've got 7 pi over 6, which is my 210 degrees. I have my 3 pi over 2, which is 270 degrees. And I have my 11 pi over 6, which is 330. Again, I knew that I should have reminded you it was only from 0 to 2 pi. That's why I knew to stop. We're going to start plugging numbers into our derivative. So our derivative is right here. I'm going to do this as quickly as possible. What we're going to do is we're going to test a value. Maybe we'll test pi over 4. Well, pi over 4, that would be positive, positive, plus a positive. So I know that it's increasing here. Everything's positive for sines and cosines in those. Now we're talking about in the second quadrant. So I know the sign is going to be negative in the second quadrant. So I'd have a negative times a positive here, which would be negative. Now I'm talking about in the third quadrant down here. So I know that both sine and cosine are negative. So when I start multiplying a sine times a cosine, I'll get a positive value, and then I'm adding on some sort of negative value. But when you plug those in and you use your calculator, you'll find out that you have a positive value here. And then the last thing we're going to try is right in through here, we need to test a value between 270 degrees and 330 degrees. We'll find out this is negative and then this is positive. Really, once you have a trig function and you find out it's positive in one area, you can go ahead and put negative, positive, because there's no areas of discontinuity that are taking place. So we could label our increasing intervals as negative, actually just from 0, because we're only talking about the interval from 0 to 2 pi. So I'll say from 0 to pi over 2. I will say from 7 pi over 6 to 3 pi over 2, and then my other one would be from 11 pi over 6 to 2 pi. Then my areas of decrease would be from pi over 2 to 7 pi over 6, and from 3 pi over 2 to 11 pi over 6. Lastly, we'll go ahead and find out whether they're maxes or mins. So we have relative max here because it increases, then decreases, then increases, then decreases, and then increases again. So I have 2 relative max. Those would be at pi over 2 and 3 pi over 2. The way we're going to get those y values is by plugging those back into the original. I'm not going to have time to do that on this video. The minimums would be then at 7 pi over 6 and 11 pi over 6. Again, I'm not going to have time to do that in this video, so we could discuss the rest of that in class.